diverse in terms of language. But if that's something in common, we like to break things. Yes. We feel happy when things die and we find out why. So a little bit of history of fuzzing in the world. Mangami was one of the first fuzzers written by Zalewski, 2004 I think. It's an HTML fuzzer. JS FunFuzz and DOM Fuzz. They're one of the few main fuzzers that we have for Firefox, and JS FunFuzz is for the SpiderMonkey engine. DOM Fuzz is for the DOM sections of the Gecko platform. If you have access to these slides, for those who just came in, this is the GitHub page that you can make a note and go and access it later. And you can just click on the links to find out more. We also have LangFuzz. AFL, American Fuzzy Love, is also another well-known fuzzer. Peach and Dharma. So why is this successful? Now, as of last year, these two fuzzers, JS FunFuzz and DOM Fuzz, have found over 6,000 bugs. And more than 12% of them are rated SAC critical. So if we don't find them, someone else will, right? We release it, it goes out in the wild. People try testing it, and they find problems. And if we're lucky, they'll report to us. If we're unlucky, they'll just sell them to someone else, or they use it for personal gain. Some of these bugs are so severe that you might be able to take control of someone else's computer from a remote location. And we do have bug bounties that we pay out for them. A use after free, in this case, may possibly be worth $3,000 to $5,000 US. Both Mozilla and Google have such programs. And over the years, fuzzing has been mentioned in many conferences around the world, even as early as 2005. Now, Black Hat and DEF CON are very famous hacker conferences. They're held every year in August in Las Vegas. Black Hat is a little bit more corporate, happens on the weekdays. People come in suits and shirts. DEF CON is a little more casual, happens on the weekend. You get people who like hip hop and rock, and the whole hallway is filled with basically a different kind of people, a lot less corporate. But some of these talks are by people who are really, really smart, some of the best minds, best security minds in the world. And also Pwn2Own is a competition, a browser hacking competition held in Kensec West in Vancouver. It happens probably in March every year. And every year, except for last year, I think, people try taking down the various browsers in use in the world today, like Firefox, Chrome, Internet Explorer, and so on. And when they're successful, the headlines go, oh, Firefox is hacked, Chrome is hacked. Now that may be a publicity stunt, but it's actually a good thing that it's reported somewhere. If we gain access to it, we fix it, and the users will get the patch eventually. If not, if it's used for personal gain and no one finds it, then it may be a security problem for years to come. One of our ex-CTOs, Andreas Gao, once said that he would never write a JIT compiler again without Jesse, who is a colleague on my team. Basically, when we create new optimizing engines on top of SpiderMonkey, there's quite a few now. That's TraceMonkey, that's JagerMonkey. The shirt that I'm wearing now represents BowderMonkey, the latest one involving WebAssembly. So all these are optimizing engines that make JavaScript run really, really fast. And we find so many problems right in the initial development stage. It's a lot easier for developers to fix these problems because when we report the bugs, we'll give them a nice 3-line test case. We'll give them a stack. We'll tell them what platforms it happens on, 32-bit, 64-bit. We'll tell them on what revision it happens on. And sometimes, or most of the time, we'll give them a bisection. We're able to tell them 3 months ago on this particular day, you landed this patch and it caused this bug to happen, or it caused this problem to show up. So if you're a developer, you may be able to think, oh, at that point in time, 3 months ago, I was doing this, and yeah, you may be right. It may be me. Sometimes it's not 3 months. Sometimes it's as fast as 2 days. So if you're a developer, it's always easier to think about what you're doing 2 days ago, rather than, oh, this problem was found, and it was caused by me 3 years ago. I don't remember what I did 3 years ago. In fact, I don't even remember what I was talking about half a year ago. The other thing is we are able to go directly to the developers. We skip the management level. I don't need to go to any manager. I don't need to go to the development team's manager and say, hey, your team caused this problem. Please find someone to fix them. What I usually do is I find a person, hey, let's go out for a meal. Let's go out for a drink. And we're all drinking, we're all happy, and I'll just sneak in and I'll say, oh, by the way, this bug, da, 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 da. Now, if you're friends with that person, it's a lot easier to get things done, right? And the person might even appreciate you doing so because you're giving him all the information, or most of the information that he needs. You're giving him a nice test case. He doesn't need to go through and download a 3 megabyte test case and then figure out exactly why the problem is there, because you've done everything for him. So some of the possible focus areas for finding security bugs are the following. If they're written in a safe language, hint in C++, if they're less sandboxed, all right, if they pass input, implementing boundaries as well as maintaining invariants. Some of it's pretty technical. These are the places where we look for problems, right? Boundaries is a very big clue. And if the developer was working on something like garbage collection, a new GC, a new particular generational GC feature just 2 days ago, and you're able to provide him a nice comprehensive report, he or she would just pounce on it just like that, because it's always better than some random crash that you're getting in a browser. It's a lot harder to triage those. Some of the good starting points for fuzzing. It's when you can, it's if you can isolate a particular module. For example, instead of testing the entire browser, it takes time to start up and shut down. I just use a shell program. I just have a spider monkey shell. It's very fast to start up and shut down. So, assuming that I shut down the program after 3,000 iterations, there's less overhead. Or I get a media shell, where the media shell just involves testing media formats, media files that you throw at it. After you find a bug, after you report it, and after it has been fixed, after release management decides that, it doesn't just exist on the development branch, it also exists on release, and they land it there. Once the patch has gone out to most users over a period of time, the test case should be landed. To ensure that the bug doesn't happen again, but more importantly, we use these test cases and we continue to make mutations on them. If we find a test case that breaks at 30, the value number 30, a similar problem might exist if the variable was at value number 31 or 29. It's like a door. If you find a problem at the hinge and you fix the hinge, But that's just the top hinge, right? The bottom hinge might have the same problem, but it might not show up until later. It might not show up until a different set of conditions. You never know. So if your project is large enough, if it involves hundreds of developers around the world sitting behind a computer, and many of these people do not have English as their first language, you face many problems. Number one, you're going to face a lot of bugs, right? That's for sure. Not enough tests. Usually people don't really focus on tests in the start. You're going to create some new thing, and that's more exciting than running boring tests. You always suffer from lack of manpower. And resistance. What's resistance? Resistance to fixing fuzz bugs. If you're a developer and you're under huge time pressure, would you fix the 3 bugs that involve your new feature because it impacts your bonus? Or are you going to fix 40 fuzz bugs that this particular fuzzing team found on the side? Naturally, you're gonna do the things that involve your paycheck, right? But bear in mind that 40 bugs, if you don't fix them now, you're gonna have to fix it later. Why not just deal with something that you were just involved in doing like 3 days ago, then have to switch focus 2 months later and try and think what you were doing back then? It's a lot harder. And sometimes it's also difficult to find serious bugs. Like, I may be able to find some spelling errors, for example, but they aren't critical. They aren't the ones that black hat hackers try to use the application and exploit millions of users worldwide. And fuzzing can help with every one of these. By creating automated test cases, you are creating new bug reports, you are solving the problem of having no tests, because you are creating test cases. Actually not you, but your computer, right? If you worry about manpower, just get more computers. If you have not enough office space, move them to the cloud. EC2, press a button, boom, 200 new virtual machines. Of course, with scaling comes a different set of problems. But that's another thing, right? What we want is test cases. What we not want is bugs. And resistance is going to be a little bit harder to overcome, right? You're going to have to take time to be friends with them. Right, so basically, in summary, too many fuzz bugs, there's resistance. But over time, they realized the value, and we became the fuzzing team. We became the QA, sort of QA team for them. And right now, the developers sometimes try to get fuzz bugs quicker, so they don't have to deal with the real life ones. We are concise, right? Sometimes we are duplicates, and sometimes developers wait for us. If they see a real life test case, they might just wait like 24 hours to see if the fuzzing team reports something, and they'll just fix that, and most of the time you will actually fix the real world problem as well. It saves them a lot of time. A community contributor from Japan, Arai-san, mentions this: effective way to find corner cases, and it can also provide more information on how to fix it. All right, this person is a community contributor who has made many great patches for SpiderMonkey. And we're good friends. I make sure we're good friends. All right, so make sure we're working as a team. They fix first bugs. We ensure that tests get landed, and then we get more starting points for fuzzing. There's a feedback loop, right? We're able to tell the developers, hey, we found more problems in this particular part of the code. Is it really worth it? Is it worth having so many bugs? E4X is a good example. E4X is a feature that has since been removed, but it was responsible for maybe 30% or a large proportion of security bugs in the software. All right, some things that developers can help to find more bugs: add more assertions, testing functions. We will test components in isolation, as well as make use of memory safety tools. these testing functions that I mentioned in the first point, it's really up to the developer. Maybe some new way to trigger GC at a particular moment. Usually we don't define what those are. Alright, what to look at first? Security bugs are going to be higher priority. Fuzz blockers, for example, if you have a printf that just spews 10 megabyte of log every time, it's not a security bug, but it prevents us from finding new stuff efficiently because we're just generating gigabytes of text files that are essentially useless. And the more we discover, the less other people find. And generally, the more they are discovered, as we scale up. So generic fuzz bugs are generally lower priority. It's up to the developers to manage them. Alright, so some of the pitfalls are if we use automation frameworks, and if these frameworks get outdated, you're going to have to write a new fuzzer from scratch. So that's why some of our fuzzers are self-hosted. JS FunFuzz is written in JavaScript itself, so it's running on the engine itself. Device is not powerful enough. ARM is not as powerful per core compared to Intel. So what we do is we simulate ARM binaries on Intel. And then we can scale that up on EC2. Alright, so patches have to land on trunk first. We back out when regressions occur. Some of these, we have to follow these strictly, so it will help to ensure effective fuzzing. And this is the workflow. We have fuzzer, we have instrument the code, we monitor such that we know when it fails. We bucket different crashes together. We reduce the test case from thousands of lines down to effective 3 lines. And then we bisect the code. We find out when it was introduced. So I'm just going to breeze over these quickly. These are some of the presentations that my team has made and myself has made. These are the projects. Most of it is open source. It's on GitHub. You can play around with it. I will skip this for now. Some of it is pretty technical to set up, but we welcome contributions. And at this point in time, we have 3 hats to give up for 3 questions that I'm going to ask. It's supposed to be a Q&A for you, but because we're running out of time, I'm going to do the Q&A in reverse order. Yeah. All right, so first question is, what are 2 types of fuzzing? Raise your hand if you know the answer. All right, the gentleman over there. All right, generational and mutational. Very good. Please give him a round of applause. All right, second question is, after a bug has been found, what other information should you provide? All right, good. Gentleman over there.
Trace dump?
Pardon?
Trace back?
Yep. Dump, a stack dump. Yeah. Correct, true. Thank you. Round of applause. Thank you, everyone. Now I feel like a celebrity show host. Oh, that's fine. It's one more left only. After the bug has been fixed, what should you do with the test case? It's the very last one. No, not you. Sorry. What should you do with the test case after the bug has been fixed and landed? Yes, the gentleman over there.
Run it again.
Pardon?
Run it again. Run the test again.
Run the test case again?
Yes.
Yeah, true. You have to run the test case every time. But yeah, that's correct here. Thank you. Round of applause to him. All right. So, all right, that's it for now. That's all the time I have. Please feel free to come up to me and ask questions in any of the languages that you're comfortable with, and I'll try to reply in anything that I am comfortable with too. Thank you. Thank you.
Thank you, Gary.
去的，你看就是一个操作这个